Promises and event loops are some of the complex topics in JavaScript world. And after today's video, I guarantee you that it will not be the same. You will understand most of the stuff like how promises work, how their execution carried out throughout the JavaScript runtime, how they are implemented internally, and how you are supposed to use the promises. So without any further ado, let's start the video. But before starting the video, make sure you like the video and you subscribe to our channel to support content like this. So the first thing is understanding about JavaScript runtime. Every language has two components. One is heap, other one is stack. Both of them are present in our main memory, which is RAM, and every global variable, local variable, function, declaration, everything goes in one of them. So we will be looking into the details of heap, stack, the task queue, the event loop, the C++ APIs that you can see on the right, like set timeout, session storage, URL, fetch, local storage, everything about it. So this is the JavaScript runtime. And the another part is the event loop. You can see a loop which is looping continuously is the event loop of JavaScript, and it's also the most complex and famous topic to learn, obviously, for the beginners. And let's start the execution, right? So we have this code where we have some function. Although this function is not summing up the integers, it's also like doing subtraction and multiplication and so on. But let's keep it as sum of A and B, right? So let's see the simple execution, how your stack is used when you run some instructions, when you run some code, right? So this is our function where we are summing up the integers, then we are subtracting them, then we are multiplying them, right? So let's see the execution, how they are like executed in the stack. So first of all, we will carry out the function itself in the stack, and then the stack data structure will be used to include other functions like console.log of a plus b, a minus b, a into b, right? And all of these functions will be used in such a way that it will follow last in first out, which means whoever is pushed at the last will be popped up first from the stack. So here you can see we pushed sum of 5, 3, the function itself first, and then the function console.log of 5 plus 3, which is a plus b, right? The parameters. And this function will be executed immediately because it's not a async function. But is async function, we'll look into that. But this will produce an output of 8. Now console.log of a minus b will go. Now this will be popped out, and this will be carried out to output the value of 2. And then again a into b, which will be 5 into 3, 15. Fair enough, simple enough, easy enough, right? But what happens if we make it a little bit complex and run two functions and they are both nested in themselves, right? Let's see. So here we have one sum function which is again summing up and subtracting something and multiplicating the integers, but we have sum, we have function 2, right? And function 2 is being called from the sum function itself. Now when you will run sum function, it will be pushed to the stack. We can't pop up the sum function because the execution of sum function is still in the progress, right? So then we will push console.log. Now there is no dependency to run console.log. There is no other dependency, and you can pop it out and print the output, right? Which is 8. Now we will push function 2, and we can't pop function 2 immediately because there are some dependencies of function 2, which is console.log hello world. We have to console.log, which is print hello world first, so that we can pop out function 2. So we will push console.log. We will run this console.log, which is hello world. We will print hello world. Then function 2 is done, right? Then again we will print console.log a minus b, a into b, and so on, right? Fair enough. Now let's come to the promise. You can see any of the code block. Now here we have again some function. We are doing a plus b. Then there is some weird thing coming up, right? Which is set timeout, and in set timeout we have some weird arrow function and console.log I am async web API call. Now what exactly is the web API? So on the right you can see set timeout, URL, local storage, fetch, session. All of these functionalities are a part of Node.js environment or JavaScript runtime environment, which is like a set of APIs implemented in C++. We will see how promises are implemented, but for this time you can see this set timeout is present in our C++ API box, right? So this set timeout will be carried out by another thread, and I will say a thread which is present in our operating system, not from the thread of JavaScript, because JavaScript has only one thread for the execution, right? So what I meant by JavaScript or Node.js is single threaded. Now let's say we have written 3 functions or 3 instructions in sequence, right? We have written, let's say, sum 5 3, then function, then console.log. They are written one by one, line by line, right? How JavaScript will run them? JavaScript will not run it parallelly, or even if we want to run it parallelly, it will not run functions parallelly. So first, the loop, or I would say the CPU or memory will be allocated to first instruction, right? And I would say ki this instruction will take some CPU, it will run, and other instruction like other function will keep on waiting to come so that the first instruction will get completed, right? So then function 2 will run, its execution will be carried out, and then the another instruction will keep on waiting until function 2 will complete its execution, and then console.log a plus b will run. And then again, if there is no other function remains, then our main function, our main thread will be popped out, or I will say it will stop its working, right? So JavaScript is I would say blocking in nature and only runs one task at a time, right? It will block any other task which are in sequence. So to solve this, we come up with a phenomena called promise or event loop. Today we will be looking about what promises are in detail. So what is the structure of promise? Let's start from the basics, right? So promise, we can execute a promise, we can initialize a promise using new promise, which will give you an object of promise. Here in this object, we have one function, anonymous function, or I would say callback, where you have 2 parameters, resolve and reject. What is resolve and reject we'll see, but as of now you can see this promise is resolving something. It is resolving some result, or you can say it is returning something in return, right? Okay, fair enough. So then we can chain the promises using then, using catch, right? So then will be used whenever your promise resolves to a result without any error. But then the catch will be used where in the callback you will accept an error, the error which is being thrown by the promise, right? So this is the promise syntax, which is promise will run some asynchronous operation. Now what is exactly is asynchronous operation? Let's say I want to read a file, or I want to query some database. Now this file read or database read can take any undeterministic time. We don't know the exact time that these databases or file reading will take, right? So these functions are simply asynchronous function which are carried out by different thread of operating system, or I would say the C++ APIs, right? So in that case we will use promise, and whatever the result of those file read or database will come, those result either will throw error or it will give you some result, right? If it is a success, that success might come from the database read call. It will give you a resolved thing, which is operation succeeded. Otherwise, even if it will throw any error, it will go in else condition and it will raise some error. Now the promise has only some states that we'll see, but as of now you know that promise will either resolve or either it will throw an error, right? Now let's see how promises are exactly working, right? Before that, let's see some of the examples of promises, how to use the promise before going into how they work, right? So there are different approaches of using promise. So all of them are listed here. We will see them one by one and in sequence, right? So let's see the first promise. So this is the example that we have used just recently, right? Here again, the promise is there, resolve, reject, callback is there, and set timeout is we are using set timeout API of C++, right, from the JS runtime, and this is resolving task completed successfully after 2 seconds, which is 2000 millisecond, right? So this set timeout is a simple callback function with some delay. But what about this? This is again the same, right? We are again just rejecting. In previous one, we were just resolving it. The promise was being resolved and the async task dot then will be executed. But on the next one, the dot catch block will run, right? So fair enough, right? So now what about this promise? Now here we have again a promise with resolve reject with again set timeout, which is resolving an integer value, which is 10, right? After 1000 millisecond, which is eventually 1 second, right? So first task dot then, what it will happen, it is resolving, right? We are using resolve, we are not using reject. So it will resolve successfully, and we are resolving some hard coded value which is 10, right? So dot then will run, the result will be passed, whatever the resolve result is will be passed to the callback, and output will be 10, right? The console.log result will output 10, and then we will return 10 into 2, which is 20. This 20 will be passed into the another then block, because we are again returning some result to the another chain, and the second chain is we are multiplying the result by 3 and we are printing the result also, right? So this is one of the approach where you can chain the promise up to how much results you can, right? You want. Now this is again a promise where you are waiting for all the promises to complete and then run, right? So here you have promise 1 where you are just resolving 1 after 1 second, then another promise where you are resolving 2 after 2 seconds, then another promise where you are resolving 3 after 3 seconds. So here we are using an function of promise which is all, and we are passing array promise 1, promise 2, promise 3, 3 promises, and then we are waiting for all of those promises to resolve to some value, because here we are hard coding the value which is 1, 2, 3 in the resolve function. So they will resolve immediately after 1 second, 2 second, 3 second, whatever the delay we are giving, right? So after, I will say ki whenever those 3 promises will get resolved after some time, only then promise dot all will give some result, and dot then or dot catch will run. So this is another type of chaining in promise. And again here you can see how we are using promises in async await function. Now what exactly is async await function? They are similar to the promise. They are similar to the promise in a way that they will be run by C++, or I would say the task queue or microtask queue, right? They will not be run in the simple stack. How they will be run, we will see, don't worry. But this is another example where we can use async await with promise, right? So here we are using again delayed task, which is returning you a promise of resolving to task done after 2 seconds. And in this function we are just using async await, which is this function will run in sequence and it will wait for the promise to resolve until the result is equal to await of delayed task will come. It will not run the further line. And this whole code block is, I would say, async function, which is which will wait for the promise to resolve and then it will run. Now how is it different from the another promises? Like if you declare a promise and then on the another line there is something else to run, right? Why the another line should wait for the promise, or when it should wait? That is a part of async await, or I would say async functions or async programming, right? That we'll see, don't worry. Now here again another example where you are just using the race function, right? And I would recommend to read more about it, like what dot race is, right? It is not frequently used, but it is one of the functionality right there. So yeah, it is there. So enough about promises syntax. Let's see how promise execution works exactly, right? Because that is more important. Syntax anyone can learn, right? Let's see what promises are, like how they run, right? So here we have again the same example that we took before, and to simplify the things we are removing the heap. Heap is just to store the global variables, to store the dynamic arrays and all, but here we are making this thing simple, right? So here we have some function, right, which will run first because it is called out first, right? So console.log will be pushed to stack. Then what will happen? Console.log is not a async function, or it will not be carried out by C++ API. So fine, it will run. Then there is a set timeout function, right? So this function is a part of C++ API. So this API will go here and a timer will start, which is 2 seconds, right? Now console.log a minus b will run. Again, this is not a part of any C++ dependency, so it will run right away. And again console.log a into b, again right away. So then after running some function, we will pop this function from the stack, and then the promise will come into the picture. Now this promise will go into the C++ API, right? Now this promise has resolve and reject, and you can see that resolve, we are using resolve and we are hard coding the value. We are not making any database call and then resolving the database call result, right? We are just hard coding the resolve function, which is, it will always get resolved in couple of nanoseconds. I mean almost immediately, right? Now the stack is empty. your callback stack, which is the stack where your sum was there, right? This stack, it is empty. So what will happen? Now when the stack is empty, event loop looks for the stack. If it is empty, then only it will look for the task queue and microtask queue. So the task queue and microtask queue are the queues which will contain the callbacks, the promises callbacks, anything which is which is being run by the C++ API or the thread which are present in our operating system, right? They are not being run by the JavaScript main thread, which is a single thread. So here what will happen? Both of the callbacks, because promise will resolve immediately and set timeout will resolve after 2 seconds, which is a delay that we have given to that function, right? So these both callbacks will be here, and the callback of promises will always go in microtask, and the callback of some APIs goes to task queue. And in next video we will look in more detail like why this distinction is there, right? Why this distinction is there, why two queues are there, how many queues are like sub queues are present in microtask and task queue, and that will be a part of event loop. Let me know in the comments if you want that video also. So these two callbacks will go according to the priority they will be ran, right? So the priority of microtask queue is always more than task queue. So like the task of IO where we are reading database, the priority of that task might be less than running a promise. I'm just making up, right? In the next video you will exactly know what is the priority of different queues and sub queues. So here we got the callbacks in microtask and my task queue. Event loop will look into it. If any callback is present in microtask, it will run, it will print. Now again it will see microtask queue, it is empty. Now it will go for task queue and it will run and it will print. Now this is the execution of promise, how they get resolved, right? How they are like their callbacks are being pushed to the queues, and event loop only looks for those queues when the stack is empty. Let's look into the internals of V8 engine, which is our runtime engine, or I would say the JavaScript runtime environment, which is implementing the promises, JavaScript promises and all. So V8 engine is the capability that is being provided so that JavaScript can execute out of the browser. Even Google Chrome used V8 engine. I will put out the link of V8 engine in the description so that you can, if you want to dig deeper, even after this video, you want to explore more, you can go into the C++ code of V8 and you can set up in your local system, right? So let's look into it. So if you will install the V8 engine in your system, you will see v8 promise.h, right, which is a starting file. I will run you through this code, and after this it will help you to dig more deeper, right? So in promise object, right, in promise object we have promise state, which is pending, fulfillment and rejected. Promise has only 3 states, which is if it is if it is in progress, it will be pending. If it is fulfilled, like the result is success, then it will be fulfilled, and if there is any error, then it will be rejected. So then there is a resolver, right? And in this resolver again we have 2 things, we have 2 functions, which is resolve, reject, and we have get promise, right, which will return the promise being run. So that is there. In the resolve, if you will see, we have 2 values, which is context and value, right? We will see what these functions are, what these classes are, right? So context is nothing but it has some variables like isolate context and microtask queue. So whenever you are running a promise, every promise has a queue associated in which this promise will go. So if you'll read more about it, the context object has isolate, right? So the isolate represent an isolate instance of V8 engine, right? It is isolated from other other tasks being run. V8 isolates have completely separate states. Objects from one isolate must not be used in other isolate, right? So these isolates and microtask queue, they are associated with promises, right? So now another thing is function. Now the context, we saw context and we have value. Value is just like it will hold some data. It is a class which will hold some data, right, about the promise state, about everything else. So what about function? Function, if you have worked in Java, if you have worked in TypeScript, you must have known about functions, where you can pass functions as a parameter, right? So here you can see on the right, v8 function.h. In function we have again the context, like the V8 context, the engine context, what is the state of the engine, where is like the progress of engine, how the promises are executed, how many promises are pending. All of the context is being stored in the context object. Then you have data has again the value itself. Then you have the length, then you have the behavior, then you have the side effect, right? But you can read this function classes create a function in the current execution context for a given function callback, right? So you saw, right, there are callbacks whenever you resolve a promise. Everything else has a callback, right? Promise has a callback, set timeout has a callback, all those functions has callback. Those callbacks are acted like they are acting as a functions here. And functions has function callback, which will be called whenever they will fulfill or reject. The most important thing that you have to notice is JS promise, how JS promise is being implemented. So JS promise is JavaScript promise again. So in V8 engine, it has result, like it checks the promise is settled and return the result, right? This function. And then this is reaction. This is the most important thing here. Promise object has its state, right? It has reactions, right? Promise reactions. Now all the things are being handled in the reactions itself, the callbacks, everything, right? Then they are made as a promise reaction job task. That we will see, don't worry about it. Now this is the reactions. It checks if the promise is pending and return the reactions. What is the reaction, right? We will see that. Now here the fulfill function is there if promise is able to fulfill, right? And then if it is not able to fulfill, we will use the reject function. If it is not fulfilled or rejected, then it means it is being resolved, right? So I'm giving you these glimpse so that you can install V8 engine in your local system and you can see the implementation, and these classes only you have to see, right? So then you have trigger promise reaction. This is the thing where magic happens. Now these promise reactions has the isolate function, like the isolate class, which will represent the V8 context in isolation. Then it has reactions. Now these reactions are most important ones, right? These has promise fulfillment reaction, promise resolve reaction, reject reaction. We'll see how it works in JavaScript also, right? Now you have like promise important terms here are, again, I have told you promise reactions, promise reaction job task. Now you have promise reaction, which will contain a list of promise reaction jobs, right? Like if there are promises, set of promise, and they are being fulfilled, reject, all those promise reactions will be stored somewhere in the handler, and those promise reactions will be made as promise reactions job task and will be pushed to the microtask queue, right? So here, if you will see, I am making it simple to explain what promise object, or I would say whatever new promise we are using, creates. It has promise state that we have seen, right? It has result if it is being resolved. It has promise fulfilled reaction, fulfillment reaction, and promise rejected reactions. This is an array, right? Here what happens? Again, we are taking an example, a fairly simple example, where we will again, whenever the promise is being loaded into the memory, its state will be pending. It's not resolved, right? So after resolve, because I have hard coded the value, it will resolve immediately and the promise state will be fulfilled. Then we will use the chaining, and then if it is resolved successfully, then we will run this callback, which is console.log promise executed successfully. And this callback, this function callback, will be made as promise fulfillment reaction job task and will be pushed to promise fulfillment reactions array. Now this promise reaction array is strictly coupled with microtask queue, right? And all of this stuff is being run in the V8 context, which is isolated, right? So if this promise is being executed, this whole state will be isolated. It will not interact with any other promise, right? So this event loop will run because the stack is empty. There is no other thing to run, the sequential thing, yet the sync thing, right? So now the async things like the microtask queue and task queue can run. So this callback will go here. Event loop will trigger this, will push to the stack, and it will run. Now again, let's take an example, a fairly simple example again, where we are resolving a value and we are returning some result. Now when the promise is being loaded into the main memory, its state will be its object state. Again, promise object is also present in the memory. Its state will be converted to pending. Then you will resolve. Its result will be 5 from undefined. Then we will use the callbacks, right? The callback here is result, just log the result in multiplied it by 2. what will happen here? The result that is resolved as 5 will be pushed to this callback, right? And this microtask queue is also loaded into the memory, and this event loop looks for any result if present, right? It will see if there is any callback present. There is one callback, it will schedule that, it will push that to stack, it will run it, right? So this is how promises runs. This is the promise object, and you can refer the C++ classes of this promise object and can see how the array is being constructed, how they are like the promise fulfillment reaction job is being pushed to a queue. Those implementation are hidden into the V8 implementation, and if you want the full details, you can refer to a blog that I have pinned a link of, right? So for more details, in-depth articles like this directly into your inbox, then just you have to do one thing, which is subscribe to our newsletter, where we put the summary, the code example of these videos directly into your inbox. Stay tuned, we'll meet in our next video. Till then, bye bye.